Hi students, welcome to Jce Connect. We are discussing about module 4 of the subject basic electronics, and previous two lectures we have studied applications of bipolar junction transistor. Today we'll be discussing about feedback amplifiers. So uh, in this lecture we are going to discuss about what exactly you mean by feedback, what are the types of feedback, what do you mean by positive and negative feedback, comparison of positive and negative feedback, applications of positive and negative feedback, and then we'll be discussing about a block diagram of negative feedback amplifier, and we'll be deriving the expression for voltage gain of negative feedback amplifier. And in the end of this lecture we'll be discussing about properties of a negative feedback amplifier. So we'll start with what is feedback. So you know that basically feedback is a process of giving some fraction of output energy back to the input. That is, it is a process of feeding back or returning back a part of the processed signal to the input side, so as to effectively enhance or diminish the input signal. That is, we are giving some part of the output energy back to the input, and this fraction of output energy which we are giving back to the input, which may enhance the effective input that is applied, or it may diminish the input that is applied. So depending on whether it is enhancing or diminishing the effective input applied, we have two different types of feedback, and those two different types of feedbacks are called as positive feedback and negative feedback. So what do you mean by positive feedback? When the input signal is enhanced, that is, when the fraction of output energy which is given back to the input, if it is in phase with respect to the source input, then the effective input applied to the amplifier will be more, or it will be enhanced, and that feedback is called as positive feedback. Similarly, when the fraction of output energy given back to the input, if it is out of phase with respect to the source input signal, then the effective input applied to the amplifier will be diminished, and this feedback is called as negative feedback. So positive feedback will increase the effective input, hence it enhance the input, whereas negative feedback will decrease the input, that is, it diminish the input. So we have two different types of feedback. Those are called as positive feedback and negative feedback. So both this positive and negative feedback are explained here with the help of a diagram. So you can see here in the first case the output signal is taken. So here in fact that beta indicates how much fraction of output energy we have taken and given to the input. So in this first case, the output signal, the fraction of output energy which we have taken, you can see here it is in phase with the input. The fraction of the output signal which is taken, it is in phase with the input, hence the effective input applied will be more, and obviously the output also will be more and the gain will be more, and this type of feedback is called as positive feedback. Similarly, in the second case, you can see that the fraction of output signal which is taken and given to the input is out of phase with respect to input. Both are 180-degree out of phase. As a result, the effective input applied to the amplifier will be less, and because of that output also will be less and the gain will be less. This type of feedback is called as negative feedback. I hope it is clear. Positive feedback, both the input signal and the feedback signal are in phase, whereas in negative amplifier the fraction of output signal and the input signal, they are out of phase, right? So these are the two types of feedback. So normally positive feedback is employed to produce the signal generator such as oscillators. That is, positive feedback is used in oscillators, that is to generate oscillations, which we'll be studying next in this chapter, whereas negative feedback is normally employed in almost all the amplifiers to enhance or to achieve certain special characteristics that are not obtainable from the basic amplifier. So first we'll be discussing about negative feedback amplifier, and we'll be explaining like why this negative feedback is required in amplifiers to achieve certain special characteristics that are not obtainable from the basic amplifier. And the next part of this module will be discussing about the oscillators where we'll be using positive feedback. So quick comparison between the positive and negative feedback. You can see here in negative feedback, the feedback energy is out of phase with respect to input signal, whereas in positive feedback, feedback energy is in phase with the input signal. In negative feedback, obviously the gain of the amplifier decreases, whereas in positive feedback, gain of the amplifier increases. Similarly, negative feedback stabilizes the amplifier, or the gain stability will increase, whereas in positive feedback stability will decrease. This also we are going to see shortly. Then noise and distortion is more, noise and distortion decreases in negative feedback, whereas noise and distortion increases in positive feedback. Since in negative feedback gain decreases, obviously there will be increase in the bandwidth of the amplifier, whereas positive feedback, since gain increases, there is a decrease in the bandwidth. And a negative feedback is used in almost all amplifiers, whereas positive feedback is used in oscillators. So this is the quick comparison between the positive and negative feedback amplifiers. So now we'll discuss what exactly the negative feedback amplifier is, what is its block diagram, and how we can derive the expression for voltage gain of a negative feedback amplifier. So this is the block diagram of negative feedback amplifier. You can see that the heart of this negative feedback amplifier is the amplifier with gain A, or amplifier with open loop gain A, then the beta, the feedback network or the feedback fraction, right? This is the amplifier, this is the feedback fraction or the feedback network, and this is called as the mixer, which will mix the source input and the feedback signal to produce the effective input. So here Vin is called as the source input, Vf is called as the feedback signal, V0 is the output signal, A is the open loop gain of the amplifier, which is given by V0 by Vin, and beta is the feedback fraction, which is given by Vf by V0. So that Vf becomes beta times V0, and Vi is called as the effective input applied to the amplifier. Now here this negative sign indicates we are giving the feedback signal in such a way that it opposes the input signal, hence there exists what is called as negative feedback. And since we have given this feedback signal Vf in phase opposition with the input signal Vin, the effective input applied to the amplifier Vi will be this Vin minus Vf, and as I said, Vf here will be beta times V0, where beta is the fraction of the output given back to the input. So always the value of beta will be less than or equal to 1. When beta is 1, the entire output will be given back to the input. So beta will be always less than 1, so that the fraction of output is given back to the input. So after knowing all these things, the constituent parts of the negative feedback amplifier, now very easily we can derive the closed loop gain of this particular amplifier, which is defined as the ratio of output voltage to the input voltage, that is V0 by Vin, gives us the closed loop gain that is denoted by AF, whereas V0 by Vi gives you the open loop gain, which is denoted by A, and beta is Vf by V0, which gives Vf equal to beta times V0. Now if you understood all this thing very easily, within 2 to 3 steps we can derive the voltage gain of a negative feedback amplifier, which is a very important derivation of negative feedback amplifier. So we'll start with, so as I already told, consider an amplifier with an open loop gain A, and let beta be the fraction of output fed back to the input. Now let Vin is the source input, Vi is the effective input applied to the amplifier, V0 is the output signal, and Vf is the feedback voltage or the feedback signal. Then, as I told, the closed loop gain of the amplifier is defined as AF equal to V0 by Vin. Here A suffix F indicates gain with feedback, and if you write only A, it is called as open loop gain or gain without feedback. So gain with feedback AF is V0 by Vin, whereas gain without feedback A can be written as V0 by Vi. Now using this equation 1, we have to get the expression for closed loop gain of a negative feedback amplifier. Now if you consider the block diagram of the negative feedback amplifier, we can see that the effective input applied to this amplifier, the effective input applied, that is Vi, will be Vin minus of Vf. So if I write that Vi is equal to Vin minus Vf, and as already told, minus sign is because of the negative feedback. Now this feedback signal Vf is given by beta times V0, where beta is the feedback fraction and V0 is the output signal. So Vf is equal to beta times V0. So if I substitute this Vf equal to beta times V0 in this equation becomes Vi equal to Vin minus beta times V0. And if you rearrange the term here, we will get Vin equal to Vi plus beta times V0. That is, the external input or source input applied will be equal to Vi plus beta times V0. Now if I substitute this Vin equal to Vi plus beta times V0 in this equation 1, we get AF equal to V0 divided by Vi plus beta into V0. Now from the denominator, we'll take Vi common. If I take Vi common, it becomes V0 by Vi into bracket 1 plus beta into V0 by Vi. Now if you see this particular equation, we have got here two terms which are V0 by Vi, and that V0 by Vi is nothing but the open loop gain of the amplifier, that is denoted by A. So substituting V0 by Vi equal to A in this equation, we get AF equal to A divided by 1 plus A beta. AF equal to A divided by 1 plus A beta, and this is the required equation for the closed loop gain of a negative feedback amplifier. And from this expression, you can see that the closed loop gain of the amplifier is less than the open loop gain A by a factor of 1 plus A beta, because here we are dividing open loop gain A by 1 plus A beta. Therefore AF is less than A, that is, closed loop gain is less than the open loop gain by a factor of 1 plus A beta, and that is what is the important property of the negative feedback, that is, it decreases the gain. So from the above equation, it is seen that negative feedback reduces the gain by a factor of 1 plus A beta. Hence, negative feedback is also called as degenerative feedback. The quantity A beta in the above equation is called as loop gain. Why it is called as loop gain? Because A is the open loop gain of the amplifier and beta is the feedback fraction. So total loop, if you consider, forward path is amplifier and the feedback path is feedback network. So total product of open loop gain A and the feedback fraction beta is called as loop gain of the system or loop gain of the amplifier, and the term 1 plus A beta is referred to as the feedback factor. That is, the closed loop gain of a negative feedback amplifier decreases by a factor of 1 plus A beta, which is proved that in negative feedback amplifier gain decreases, and by how much amount the gain decreases, it depends upon the open loop gain A as well as the feedback fraction beta, or we can say that the loop gain A beta determines the closed loop gain of the amplifier, negative feedback amplifier. So after deriving the expression for negative feedback amplifier's voltage gain. Now quickly we will write down or list out what are the properties of negative feedback. Here just we are listing all the properties, and some of these properties we will be studying in detail after taking one particular example of negative feedback amplifier, because there are different ways in which we can take the feedback and give to the input. We have different types of feedback amplifiers, and all those different types of feedback amplifiers we'll be discussing in the next lecture, and we'll be studying one example of the negative feedback amplifier. And after studying one example of the negative feedback amplifier in detail, we can discuss these properties of the negative feedback amplifier there. So here I will be listing out all the properties of the negative feedback amplifier. So first important property which is obvious, that is negative feedback decreases the gain of the amplifier, and already we have seen it decreases the gain by a factor of 1 plus A beta. So reduction in gain is the first important property of the negative feedback amplifier. Second one is desensitize the gain. Normally open loop gain is not it entirely depends on the input, and there will be variation in the gain, but when we give the negative feedback to the amplifier, the gain will be desensitized. Similarly, the gain will be stable, because in negative feedback effective input applied to the amplifier goes on decreasing, so that the stability of the amplifier will be more, and hence the gain will be stabilized. Then reduction in noise. Since the feedback signal is in out of phase with respect to input signal, if there is any noise, the noise also get cancelled, and as a result of that there will be reduction in the noise when we use what? Negative feedback. And obviously if the noise is less, along with that the negative feedback will reduce the nonlinear distortion which is present in the amplifier. And one more important property of the negative feedback is extended bandwidth. That is, every amplifier will have what is called as figure of merit or gain bandwidth product, and this gain bandwidth product for every amplifier is constant. But we have seen negative feedback decreases the gain. So obviously to keep the gain bandwidth constant, the negative feedback has to increase the bandwidth or extend the bandwidth so that the gain bandwidth product can remain constant. So this is also important property of the negative feedback amplifier, that it extends the bandwidth. And obviously negative feedback can be used to control the input and output impedances. So normally input impedance should be very high for an amplifier, and output impedance should be very low for an amplifier. So if you want to further modify or further increase the input impedance and decrease the output impedance, the negative feedback helps to do that, because negative feedback controls the input and output impedances. So these are the properties of the negative feedback, and in fact we can see here all these are advantages of the negative feedback, and all these advantages are obtained at the cost of what? Reduction in gain. So negative feedback decreases the gain, but it has all these other advantages, and that's the reason why in all amplifiers negative feedback is used. With this we'll stop for today's class. So to quick summarize what all thing we have discussed in this particular lecture is, we started our discussion with what is feedback, what are the types of feedback. Then we discussed about comparison of positive and negative feedback, and we discussed about the block diagram of negative feedback amplifier, and using the block diagram of negative feedback amplifier we have derived the expression for voltage gain of a negative feedback amplifier, and we have shown that negative feedback decreases the gain of the amplifier. And lastly we have listed out the properties of the negative